algebra students. I'm with you here today to look at evaluating logarithms. In a previous vidbit, we did introduction to logarithms, looking at their definition and how the connection to exponentials. Now, what we want to do is apply that definition and some of their properties to figure out the values of log. Like, what is log 100 equal to, or what is log of 90 equal to? Some of these logs are going to be approximations because they don't compute neatly, so we use our calculator to find the value of. Others, we could use our properties of logs and the definition in exponential format to figure out what the value is. So there's going to be two main approaches in finding what the values are. In other words, how to evaluate these. So one is without a calculator. And what we do is we go ahead and rewrite as an exponential to evaluate. And the other main method is 2 with a calculator. What we have to do is make sure, convert to base 10. And approximate. So those are going to be our two main methods we'll work with today. So let's start with the outline on number 1. So evaluating logs, or ln, if it's a natural log, without a calculator. Okay, so the idea is we're going to set up some steps, and we'll have a guide for some steps. And these steps I'll outline are helpful, and of course other textbooks have other guidelines that are similar, other instructors, other guidelines. Number 1, what we want to do is set the log expression equal to x. Okay, so we're going to insert an x in there that will be the value we want to find. 2, rewrite in exponential form. Okay, then we're going to rewrite in exponential form. And 3, what we'll do is we'll solve for x, and that will be our number value, which will equal the number value you want. Okay, let's start with a few simple logs. And I will make one other note here. Some really sticky dry eraser marker here. I'm going to do some examples. And in these type of directions, they'll always be stated as evaluate. And I'll start off with the earlier log I had, log of 100. Okay, what is that going to be equal to? Okay, so what we're going to do is we're going to go ahead and set this expression equal to x. Okay, and what we want to do is rewrite it in our exponential form. So now what we're going to do is we're going to go from log form to exponential form, and we get a base 10. Remember, there's an understood 10 here. You don't see a base on a log, it's always base 10. So I'm going to rewrite this using the little mnemonic I use, base over back. So this is rewritten as 10 to the x equals 100. Now the next thing I want to do is to solve for x. The key is, and I'm going to add this, get the bases the same. So, in order to be able to solve this expression, I want to get the bases the same to solve for the x. Now, this one's probably pretty obvious what the x value needs to be, but in some cases it's not. So now I'm going to get my bases the same, and I can make this in terms of base 10. So I'll say this is 10 squared. So 10 to the x equals 10 squared. If my bases are the same, then the trick is the exponents must be equal. So x equals 2. So to solve for x here, I end up with x equals 2. So this whole expression is just equal to the value 2, and that's my final answer. Okay. So as you know, that this is, in order to solve for x, you do have to do this extra little step. Let's go ahead and look at some other ones. Okay, number 2, let's do log base 3 of 127. What's the value of that logarithm? Well, to start, let's go ahead and say this is log base 3 of 127 equals x. Okay. Now I'm going to rewrite an exponential form so that I get 3 to the x equals 1 over 27. And the key here to solving this, if you don't see it right off, is getting the bases the same. So here I'm going to say 3 to the x equals 1 over 3 cubed. So you want to recognize that 27 is the power of 3. And if it's in the denominator, you're going to go ahead and bring it to the numerator, which will change the sign of the exponent. So 3 to the x equals 3 to the minus 3. Now that I have my bases the same, I know that my exponents are equal. Okay. So what we have here is x equals minus 3, and my whole expression is equal to negative 3. Okay. Moving on. Let's try some other goodies. I had ln of the square root of e. Okay, here we have a natural log. So what I'm going to do is highlight the fact that it has a base e. Okay. So remember, it's not shown here, but there's an understood base e there, and I'm going to set it equal to x. And when I rewrite this in exponential form, I end up with e to the x equals the square root of e. Okay. And then my next step is to get the bases the same so that I could equate the exponents. So here I have e to the x equals e to the 1/2 power, which means that x must equal 1/2. So this whole expression equals 1/2. Great. Okay. A few more. Tests. Let's see if I can get some tricky ones. So 4. Let's go ahead and do something that is like, let's see here, log base 7 of 1. Here we want to set it equal to x. Log base 7 of 1 equals x. And And then we rewrite this in exponential form. So it's 7 to the x equals 1. And here you just have to think about what type of exponent would produce an output of 1. So recognize this has to be 0. So what we have here is 7 to the 0 power equals the value 1. Okay? Or in other words, I'm going to back up here. I kind of made a little jump, quantum jump there. So 7 to the x must equal 7 to the 0 power. So this is how I'm going to get the bases the same. I have to recognize that the value 1 can be made with any base when it's put to the 0 power. So now that my bases are the same, my exponents are equal, x equals 0, and this whole thing is equal to 0. And that's the value of that expression. Okay, so some other tricky ones that come up. There's a whole variety out there. Give you a moment of board wipe down pause. Okay, so number 5, what if we had log base 3 of 3 to 1 minus 2, 1 minus x. How do we evaluate this? Okay. Well, here we'd have to say 3. We'd set it equal to x, and we'd say this whole thing would be 3 to the x equals 3 to the 1 minus x. Now this one's a little tricky. When the bases are the same, then the exponents must be equal. So we would set our exponents equal. And then we end up with 2x equals 1. And we divide by 2, we get x equals 1/2. So this expression right here, when I set it equal to x, is equal to 1/2. So there's some tricky ones like that that use certain properties of logs, but you can see the logic in it. If you follow the steps in just converting it to exponential form and then finding the value, when you get the bases the same, you should get the correct output. Okay, next up, let's see. Let's look at something that's like that. Log base 3 of negative 3. What is that equal to? Well, if we set this equal to x, we could then convert it to exponential form. So this would be 3 to the x equals negative 3. And if you notice, this doesn't seem possible. Okay? If you've forgotten your properties of logs, where the domain restriction is that you could never have 0 or negative in the argument, then you probably say, well, this is not possible. There's no real solution for this. And that is the answer. So if I try to get my bases the same, it just won't work with the negative 3. Okay? Because these are not the same base. So we would say there's no real solution. And if you were trying to evaluate this in your calculator, which you could also do, if you use your change of base formula, you would get an error in your calculator. Okay? So let's move on to evaluating those in the calculator. And you have to, what you want to note is that all of these logarithms we did without a calculator can also be done with a calculator. board's not behaving very well here. Let's do the second method. Okay, so the second method, evaluating logs with a calculator. And I'll put a little note that any log can be evaluated with your calculator. As long as it is in base 10. So we need to have A equal to 10. Okay, so you could convert any log with a calculator, evaluate any log with a calculator, as long as it's in base 10. So when it's not a base 10, we have something called the change of base formula to change it to a base 10. So what's going to happen is, we're going to use our change of base formula. To convert any log to base 10, we use the change of base formula. And there's different versions, they use different letters in different textbooks, but they all come out to be the same. If you have a log that has any base A of B, this is equivalent to log base B. It's always the log of the top value over the log of the bottom, the one in superscript. And then this converts it to base 10, which base 10 is always understood. So log of B over log of A. Okay. So we have to remember this base. We have to remember this base 10.
She's still filling it.
Base 10, change of base formula. To do her logs. Sorry, I had to speak above my children in the background. Okay, so that's our change of base formula, and let's go ahead and start doing some of these. So, in the previous example, we did the log of 100, and we found that to be 2. Okay, so number 1, what if we had the log of 90? Now that's understood base 10. So if you think about this a minute, let's see. I'm going to do some doodle side work here. If I had the log of 10, this equals 1, since 10 to the first equals 10. Remember, there's an invisible 10 to the first equals 10 here. Okay. And previously, we just did the log of 100. And this is 10 to what power gives you 100? That was 2. So you could estimate what this value is. This must be between 1 and 2. Okay? So you could see that if you were to rewrite this in exponential form, you would have log base 10 of 90 equals x. And you'd have 10 to what power gives you 90? And what you're going to do, you're going to see that you cannot make this 90 in terms of base 10. You cannot make 90 in terms of base 10. So what you have to do is you have to go ahead and use your calculator and change the log 90 equals 1.95. This is base 10. Can directly evaluate in the calculator. I use a graphing calculator, so I just press log. It opens up parentheses. I put 90 in there, and this is approximately 1.95. And you approximate usually to the second decimal place. Now, back before we had these devices, we would have to look these up in tables in the back of our algebra textbooks or calc textbooks, because we use logs, you know, from here on out with all our math classes. So, interesting tidbit. So luckily for us, these values are already stored on the calculators for us. Okay, so let me go ahead and do a few more. Let's say we had log base 3 of 8. Okay. So recognize that log base 3 of 8, if we were to convert this to exponential form, we would set this equal to x, and we'd say 3 to the x equals 8. So 3 to what power gives you 8? If you notice, again, a 3 squared would give you 9. A 3 to the first would give you 3. So this must be between 1 and 2 again. So here, I look at this, I know I'm going to have to approximate it. So what I'm going to do is I'm going to change my base. First, change to base 10. So this becomes log of 8 over log of 3. Okay. Where these are both base 10. And then in my calculator, I just go log of 8 divided by log of 3, and I get the value, the approximate value. So log 8 divided by log 3 equals 1.8. So you should be suspicious if you get something like 4.5 or 10.7. So anyways, I got about 1.89, and then let's move on and do a quick ln value. Let's try ln of 7. Okay. So here's a natural log, and natural logs have a base e. So if we go ahead and put our base value in here, we have ln base e of 7, and that equals x. So what happens is, if we were to convert this to exponential form, this would be e to the x equals 7, and this I cannot make the same. This 7 I cannot make the same as base e. So what I have to do is approximate this. So in this case, just like with logs, I could just directly put this in. So ln's always have a base e, so you put it in the calculator. I get an approximate value. I just go ahead and put my ln of 7 in. So I have ln of 7, and I get an output of 1.95. And that's my value. So now you can go ahead and practice these on your own, and we will apply some of these same principles further later on with our properties.
That's what she said.
Thank you.